Now we will derive four important standard results based on substitution method. Now that is related with the integrals of the standard four trigonometric functions. Now if you remember, so far we have not seen what is the integral of, say, the function tan of x, isn't it? Because so far we don't know what is that function whose derivative is tan x, because it's not that apparent. Now let's try to address this question with the help of substitution method. Alright, let's call this integral as, say, I. Now what I will do is, we can write this tan x as sin x upon cos x dx. Right? Now to integrate this, if you observe that if we think of this cos x as t, that is if we replace or substitute cos x with t, the derivative of cos x is minus sin x, but out of that we have just sin x present in the numerator, so it's not difficult to adjust the minus sign. We can just have minus of minus sin x in the numerator, which gives us the sin x. So basically, ignoring the sign, we have entire rest of the derivative of cos x present in the numerator, so we can go ahead and do the substitution. So we say that let cos x be replaced with t, so therefore minus sin x dx will be nothing but dt. So in other words, sin x dx is nothing but minus dt, isn't it? So therefore our integral becomes, the sin x dx we replace with minus dt, right, whole upon cos x is nothing but t. So minus sign will come out and we have to basically integrate 1 upon t. So that is nothing but, we know that integral of 1 upon t is log t, that is strictly log of mod of t plus c. So therefore what do we do is, we replace now t with cos x, because this is what we had substituted for, plus c. Now if you want to take that minus sign inside, we'll have to write the reciprocal of the term which is inside the log. So therefore this is equivalent to log of 1 upon cos x plus c. So therefore that is ultimately equal to log of mod of sec x plus c. So therefore this is the integral of tan x. Right? So this also has to be remembered as a standard formula and used whenever required. Now similar to tan, we have integral of cot x dx as log of mod of sin x plus c. Now it is recommended that you try this particular standard result to prove on your own. It is also following exactly similar method. So we have seen the integral of tan as well as integral of cot here. Now let's go ahead and see the integral of remaining two functions, which is sec x and cosec x. Right? Let's see how to find the integral of sec x. Now here we use one very important trick, that is, what we do is we multiply and divide by sec x plus tan x. Now you may wonder how come or why we are doing this. Now the answer will be immediately apparent when we actually multiply that in the numerator. So when sec x multiplies the bracket sec x plus tan x, we'll get sec square x plus sec x tan x whole divided by sec x plus tan x as it is. Now here if you observe, suppose we call this denominator as some function, say t, then you will observe that the numerator is nothing but derivative of this particular denominator, because if you see, derivative of sec x is sec x tan x and derivative of tan x is sec square x, isn't it? So interestingly, we get numerator to be the derivative of denominator, and therefore this resembles the integral of the form f dash of x upon f of x dx, isn't it? And whose answer is nothing but log of f of x plus c. So therefore here we get the answer as log of mod of sec x plus tan x plus c. So therefore this is the answer of the required integral. Now there is another form also, that is we can simplify and rewrite this into another way in which the angle is x by 2 instead of angle x as it is presently here. So here what do we do is we basically express this in terms of the half angles, and to do that first let us write sec x as 1 upon cos x and tan x as sin x by cos x. So that further gives us, on merging the two fractions, we get 1 plus sin x whole upon cos x plus c, right? So what do we get is log of, now 1 plus sin x we can write as sin of x by 2 plus cos of x by 2 the whole square. If you want you can confirm this, that is say a plus b the whole square, that is sin square x by 2 plus 2 times sin x by 2 cos x by 2 plus cos square x by 2. Now sin square x by 2 plus cos square x by 2 gives us 1, and the middle term which is 2 sin x by 2 cos x by 2 is nothing but sin x by double angle formula. So therefore we can write the numerator as this, and in the denominator we use the already known identity for double angle, that is cos square x by 2 minus sin square x by 2. Alright, so simplifying that further, we have log of, if you observe the denominator, it can be broken into two factors, that is this denominator is of the form a square minus b square, so that can be factored as a plus b into a minus b. So the first factor, which is a plus b, which is nothing but cos x by 2 plus sin x by 2, can be cancelled from the numerator because there is already the square of that factor present. So on cancelling that, one factor of sin x by 2 plus cos x by 2 will remain in the numerator. So I will just rewrite it as cos x by 2 plus sin x by 2, and in the denominator we will have cos of x by 2 minus sin of x by 2. Alright, now just to simplify this further, what do? Is we divide both numerator and denominator by cos of x by 2. Here also you will realize why we are doing this. So on doing that we will get 1 minus, now sin x by 2 upon cos x by 2 will be nothing but tan of x by 2 whole upon, we get 1 plus tan of x by 2, right? So that is equal to, of course there is plus c everywhere, we should not forget. Alright, so that gives us log of, now if you remember the expression that we have got inside the log is a standard identity once again, that is nothing but tan of pi by 4, that is 45 degrees, minus the angle x by 2 plus c. So that is another form of the integral of sec x. So we have to remember both the forms, this form as well as this form, because they might be needed in the questions based on the way information is given. Alright. Now similar to sec x, we have the integral of cosec x also, which is obtained in exactly similar manner except few terms will be different. So just to summarize here, we have the list of integral of these four functions that we just now saw. So let us go over these integrals. The integral of tan x is log of mod of sec x plus c. Integral of cot x is log of mod of sin x plus c. Integral of sec x is log of mod of sec x plus tan x plus c, which is also same as log of mod of tan of pi by 4 plus x by 2 plus c. And lastly, the integral of cosec x is log of cosec x minus cot x plus c, which is again equal to log of mod of tan of x by 2 plus c. Now you can see some similarity or parallelism between the integrals of sec and cosec. If you see, the term sec is getting replaced with cosec, and the term tan x is getting replaced with cot x, but there is additional change that the middle sign is minus. Similarly, if you see the second formulae for sec x and cos x, there also the overall structure is same except that the angles are different. In case of sec, you have additionally pi by 4 in the angle, whereas in the cosec x you have just x by 2.